Hey everyone, it's Miss O'Donnell. Today we're going to learn a new type of angle called inscribed angles. So yesterday we learned central angles. Hopefully you remember central angles are located at the center of the circle. They're formed by two radii. So we have this radius BA and radius CA coming together at angle A to form a central angle. And you'll remember from yesterday that central angles are equal to the arc. So if that angle BAC is 50 degrees, arc BC is also 50 degrees. So I told you each time we learn a new angle, we're going to relate it to the arc. So our new angle is not going to be at the center. Think about what other type of lines you could use to create an angle inside the circle. So Monday we learned a bunch of different types of lines. Think about what we could use other than a radius. So hopefully you thought about chords. So here's an inscribed angle. It's formed by two chords. So we have chord BD and chord CD that share an endpoint. So they share the endpoint D. So they're forming an angle right here. Angle D is an inscribed angle. You'll notice it's no longer located at the center. It's located on the side of the circle. So I just added a central angle. So here's our inscribed angle. I'm adding a central angle on there because we already know how central angles are related to the arcs. We know that they're equal. So what I want you to think about is, does the inscribed angle look bigger or smaller than the central angle? And what I mean by that is this measure here, angle D, do you think that's bigger or smaller than this measure? So hopefully you thought it was smaller. In fact, it's going to be half as big. So if the arc BC is 80 degrees, the inscribed angle is going to be half of that, or 80 divided by 2. So the big takeaway from today is that inscribed angles are half of the arc. You take your arc, you divide it by 2. So we're going to go through some practice problems. So make sure you have a calculator handy. You can use the one on your phone. You might want some scrap paper or even a whiteboard if you have that. So here's our first problem. So remember, you can go ahead and pause the video and try to solve for x. So I'm giving you angle BDC, which is an inscribed angle. I'm telling you arc CB is 100 degrees, and I want you to solve for x. Hopefully you got 50 degrees. Remember, inscribed angles are half of the arc. 100 divided by 2 is 50 degrees. So here's another problem. This time I'm giving you the angle. Angle DCB is an inscribed angle. It's 80 degrees, and I want you to solve for arc DB. So you should have gotten 160 degrees. This time, instead of dividing by 2, we want the arc to be bigger than the angle. So we want to multiply that 180 degrees times 2. So the thing to think about is arcs are always going to be bigger than the angles. So we're going from the arc to the angle, we're getting smaller, so you're going to divide by 2. If you're going from the angle to the arc, we're getting bigger, so you want to multiply by 2. So here's another one. Solve for the measure of angle CAB. So you should have gotten 40 degrees. The angle is smaller, so we're going to divide by 2. 80 divided by 2 is 40. And now solve for the measure of arc QAR. So you should remember QAR is a major arc. It's this big one from Q front to A to R. You should have noticed this angle QSR is an inscribed angle that creates the arc. Inscribed angles are half, so we're getting bigger. 95 times 2 is 190. And just like with central angles, we're going to be missing other parts of the circle as well. So we're missing this arc SQ. And we got to be able to solve for all the missing parts. So using the information we have so far, try to find the measure of arc SQ. So what you should have done is notice that we have all of the arcs around the circle except for SQ. And we know that all the arcs have to add up to 360. So you want to add 75 plus 190, you get 265. Subtract that from 360, arc SQ is 95 degrees. So here's a tricky one. You got to be a little bit clever. Try to solve for the measure of angle LMN. So the thing you should have noticed is that I didn't give you the arc. So I didn't tell you what this arc LN is, but you should know. LN is a diameter. Diameters are 180 degrees, which means this arc is 180 degrees. LMN is an inscribed angle, so half of 180 is 90 degrees. Anytime you have a inscribed angle on a diameter, it's always going to be 90 degrees. So just like for central angles, you got to remember that diameters are 180. One thing you're going to see with inscribed angles a lot are triangles. So there's some big takeaways you got to remember about triangles. The angles in a triangle add up to 180, but they're also going to form inscribed angles. So I want you to take a second, try to solve for arc BC. So there is a lot going on, but you should have noticed that arc BC is created by this angle, BDC. That's an inscribed angle. Inscribed angles are half of the arc. So you want to multiply this 49 times 2, you get 98 degrees. So now using that same principle, try to solve for arc DB. So you should have noticed that arc DB is created by this angle here, angle C. Angle C is an inscribed angle. Take it, multiply by 2, 70 times 2 is 140. So now using what we know about triangles, go ahead and try to solve for angle B. So you should remember that triangles add up to 180 degrees. 49 plus 70 is 119. Subtract that from 180. Your missing angle is 61 degrees. So we have one last arc, arc DC. So go ahead and try to solve for the measure of arc DC. So there's two ways you could have done this. You could have seen that this arc is created by angle B. B is an inscribed angle, multiply it by 2. Or you could have saw that the circle adds up to 360. So I could have added up 140 plus 98, get 238. Subtract that from 360, you get 122. So that's a lot to take in. Big thing to remember is that inscribed angles are half of the arc. So anytime you now have an angle that's not at the center, it's made by two chords, you're going to either be multiplying or dividing by 2. So if you need some extra help, feel free to email me or join my office hours. You can begin your exit ticket now. If you have any questions on that, feel free to email me.